about us, maybe a little bit each. We got a little bit of an introduction. So I'm Dave Topham. I'm a viral immunologist. I study immune responses to virus infections, experimental vaccines, particularly things like pandemic influenza, and occasionally some other exotic things.
So my name is Martinez-Sobrido. Actually work in the same department that Dave. I work with all these hemorrhagic, kind of deadly viruses, but I usually don't see those things in university. Sometimes on Mondays, some of the students look like the zombies, depending, like this graduation weekend.
Yeah, the graduate students don't look so good,
but usually don't see this happening.
So I can make a couple of comments on the movie. I've seen this before. It's a great movie. I don't know if any of you picked up on the space probe that crashed unexpectedly early at the beginning of the movie, right? So I think that was their attempt to introduce possibly, they didn't really say that's where the pathogen came from. The other thing I'll note, because we study how bugs spread from person to person, this was not spread by aerosol. There were a number of aerosols generated during the movie. You had to get bit. Bet you didn't think of that.
Is your lab secure?
The labs are very secure. Yes, there are multiple doors you have to get through with passes and codes and whatnot. Yes.
Actually, at least in our university, we have a biosafety committee, and actually Dave and I are members of this biosafety committee. So before we do any experiments, a group of members of this committee have to review our experiments, and they decide whether or not our experiments are can cause something like this or not. And so far, nothing happened. So we're doing a good job.
It's true. We do get reviewed, and the committee tries to make sure that if we are working with things that are nasty, that they're done by trained people with the right precautions and all that stuff. None of which were in this movie.
So how would you contrast the spread of a zombie apocalypse with the pandemic or epidemic thing starting from a single source?
This is actually a lot like the hemorrhagic fever viruses, like Ebola, right? It was spread by bodily fluid, a bite, right? Intimate contact. So in that way, it was very similar.
Yeah, I'm not that familiar with Ebola. I'm more familiar with the influenza outbreaks or pandemics, not the 1918. Maybe Dave is aware of the 1918 because he's older, but I know that the 2009 pandemic influenza virus spread very rapidly. I don't know how many thousands of people in few months and over 200 countries all over the world, so it was pretty bad.
Are there any real diseases that cause effects like that?
No, that I'm aware of.
Not
They
really.
always put the monkeys like the ones that are transmitting this kind of diseases, and no, that's.
As far as we know, when you're
We
dead.
will have more money for research if things like that happen, but unfortunately they don't happen, and that's why we don't have money to do research, and we have a very small budget. I mean, sometimes we wish something like that happened.
I was going to joke earlier on that every time one of these things breaks out, it's job security for us. I mean, I hate to say it, but it's true, because Congress keeps funding it, and we keep getting grants, and we keep trying to do good work.
So, I'm assuming we all know, right, there's nothing that's going to cause zombies to exist and all that good stuff. And, there are novels and movies about pandemic viruses that wipe out most of the planet. But realistically, in terms of what is really out there and what you all work with, is there really a concern, like a realistic concern, that there could be something that was virulent enough to, wipe out a huge chunk of the planet? Is that real, or is that still super science fiction?
I'd say the Ebola outbreak we had this year is a good example of something that we thought we would always have under control. It's the kind of thing, in the past, it always burned itself out. We could always contain it by quarantine before it got too far. But it got into a population center. and one that didn't have the right support services. And then after that, it just, I mean, we barely contained it. We had to send in the military to get it under control. It got, I wouldn't want to see it get any worse than that. That, to me, as an expert, was pretty scary. And there are some respiratory things. The MERS viruses, the SARS viruses, again, those can get out of control very quickly. And our best efforts, because it takes too long to make a vaccine, it'll take 6 months at best to get a vaccine, is to quarantine.
But two things to help us with at least the Ebola outbreak was that the symptoms are pretty fast. So in a week, you know that if you are sick or you're being infected with the virus.
Yeah, that's true. It's not transmissible till you're fairly late in the infection.
And it's not like an influenza that you can get infected by aerosol contact. I mean, you need to be eating, fries.
Right, with some of these other things, you just have to be in the same
contact.
room.
Yeah.
What about the doctor who had Ebola and thought he was okay, and now they found that he's going blind? The effects are still there. Is that happening to a lot of people?
As far as I know, once you pass the virus, the virus is gone. You don't keep it. It's not like other viruses that you are kind of living with them, like herpes or Ebola. That's not the case. So unless that doctor went back to West Africa where the outbreak came, I don't know.
So was the news report inaccurate? The news indicated
No, I think-
he had Ebola in his eye.
I don't know enough about that case, but it's funny because the eye is not what we call an immune privileged site. In other words, the immune system can get to it. There are some tissues, the brain is one that it's hard for the immune system to get there sometimes. I don't know. That's an odd case. I haven't heard of any others like that yet, and so I don't think anybody really knows why it's persisting like that or how. Because Luis is right. Once you make antibodies to the pathogen and you clear it, then usually you're immune for life.
Do you have a comment on, since you work in labs, on how labs lose or have things go missing? Because I know there were a few cases this past summer out west of them losing dangerous viruses, and then they say, oh, we must have thrown it in the trash.
Well, I think it's very difficult to control everything, but we try to control as much as possible. But of course, accidents happen. I mean, it's like it can be like driving a car, right? So you try to be careful, but sometimes accident happens, and sometimes it's not in your hands to prevent that accident. Sometimes it's somebody hitting you. I was in the laboratory where they reconstruct the 1918 influenza virus back in 2005 in Mount Sinai School of Medicine in New York City. And of course, when they reconstruct the 1918 virus, they thought, oh, that virus killed 50 to 60 million people in 1918. These people is crazy. They wanna bring the virus back. They wanna kill everybody. And as far as I know, since 2005, the virus has not left the lab, and actually helped us a lot to reconstruct the virus, to understand why the 1918 influenza virus was so deadly and killed so many people in 1918.
Yeah, those cases where they lost track of things, they're almost always inventory issues, right? They didn't tick something off, on a checklist, or they didn't count right, but none of those materials have ever gotten into anybody's hands. They've just, in fact, the system worked in the way that they noticed that stuff was missing. There were two other cases when the FDA moved to a new building. They found some vials of, I think, tuberculosis in a freezer, and another one where they found vials of smallpox at the CDC, again, in an old freezer that nobody had inventoried, because really a lot of this stuff didn't come about, this sort of high-level control didn't come about until after 2001. It's,
Have you guys been in any types of hot zones at all? Like say the Ebola outbreak at all? Have you ever been in any of those areas?
No, not me. No.
no, I like to stay in the lab.
Safer.
We joke sometimes, the safest place in a pandemic for us would be in the biocontainment lab. because nobody can get in unless they have the right credentials, and nothing can get out. And it has its own air filtration system, double air filtration system, in and out. So it's actually incredibly secure.
So actually, when we want to work with some highly pathogen influenza viruses, like the avian influenza viruses that some people is scared of, we have a special laboratory where you need to dress up, you have a respirator, you have negative pressure, so everything is going to be contained there. So that's why Dave's right.
Yeah, we have both worked in BSL-3 facilities. So I wouldn't call them hot zones, but you do have to learn all the work practices and stuff. There's a lot of procedures, and you get tested periodically, and make sure you stay certified.
Actually, one of the things that you need to wear is one of they call it A95 respirator, and you need to do a fit test to see that if it's fine in your. And I didn't know that you have to shave. So the first time that I went to take the test, I didn't shave, and I couldn't take the test because with hair. So you can get things into. So they sent me home, say safe. My wife was very happy about it, and then I went back to take the test.
So with the zombies, is there any type of scientific basis for why you always have to shoot them in the head or the brain? Or is that just zombie lore?
I think it makes a good story.
But it doesn't make any sense, right?
Well, I don't know. The only way I can see that it makes sense is, they still need their brains to control all their, motion and functions, right? And without that, they can't. They're just blobs. They clearly don't need a spine, as that woman that got the thing through the middle of her showed.
It's the same thing with the vampires, where they always have to put a stick on their heart. Right?
Heart, yeah. I don't know what the history of zombieism is and where it came from, but.
What do you think poses the greatest threat, or what concerns you? Is it something like Ebola, or just the variation on the influenza virus?
I got to be honest with you. I worry, and if I were you, I'd worry most about things like influenza. It already kills more people every year than HIV or any other infectious pathogen. Every year. We forget about that. We got used to it because we have a vaccine, and it just happens every year, so we sort of take it for granted. But in reality, it's pretty nasty, right? It kills our most vulnerable, too, the youngest and the oldest. And the vaccine, while it kind of works, not so good. In fact, one of the questions my lab is working on now is, why doesn't the vaccine work? Because I get that question all the time. I get vaccinated and I still got the flu. Why? And we're trying to figure out why that happens. But flu, it can be nasty. And if we do have an outbreak, one of these avian flus really becomes transmissible in people, easily transmissible, we got a problem. It's going to be, the 2009 pandemic was bad, but it could have been worse because it wasn't a super virulent strain. But some of these other avian viruses they kill everything they infect. The death rate is 60%.
So I agree with him. In the way that influenza transmit is very easily that in this room, somebody with that virus, it can easily transmit to other people, and in the way that people travel now, that it goes everywhere, it would be very easy in a plane to get that. The 1918 influenza pandemic was so bad because we were never exposed to an H1N1 influenza virus. And the same will happen with these avian H5N1 viruses. We've never been exposed. So if one person gets the virus and the virus mutate to transmit between humans, then we will be in a bad situation. But people is trying to work in developing antivirals and vaccines, and that's pretty much what we are doing. We're not trying to create monster viruses. We're trying to create things that prevent that. And it's been a lot of controversy when two groups, one in Madison and the other one in the Netherlands, start transmitting the H5N1 virus in ferrets to make it easily transmissible. And it was a lot of concern in the media and in the society, because they thought they want to create a virus that easily transmit and kill everybody else. And the idea was to prevent, because the virus sooner or later is going to be able to transmit. And if we have it already that in the lab, we will know how to control when that things happen. So the idea is to be ahead of the virus and not behind the virus.
Now let me ask you guys, how many of you had flu this year? Right, I had it. My son had it, he's up there. I got vaccinated, right? This year was the virus that circulated was not the one that was in the vaccine. It's what we call a bad match. It was quite different. What we find actually is that many of the viruses that circulate are different than what's in the vaccine. None of them are identical. But this one was really different, so the vaccine didn't really offer any protection.
Another question. Since you're talking about vaccines, how long does it take, on average now, to come up with a vaccine? Say we had some virus that came up that you hadn't seen that was, this horrible thing. What kind of time frame is it? Shorter now than it was in the past?
Assuming you can isolate the pathogen quickly, and then you have to identify which proteins would be the target of the vaccine. Sometimes when we don't know that, we just use an activated bug. But with flu, we know a lot. So even if we, identify a virus tomorrow, it's still going to take us probably 4 to 6 months minimum before we can select a strain that the FDA will approve, that we can get into production, test it, make sure that it's safe, that it's the thing that you want to make. We even, during the pandemic, we did a very brief, very fast, urgent testing of the vaccine to see if it induced the right immune response. But that was literally, that's the fastest I've ever seen a trial done. Within like 3 weeks, we had it done, and the vaccine was licensed and to be given to people.
So another good point is that in the way the vaccine is produced, they grow the virus in chicken embryonated eggs. So they have like a bunch of eggs already safe to grow the vaccine. So if suddenly an influenza virus come up and we need to prepare a vaccine very quickly, they need all the eggs. They need to go from what it was thought to be the seasonal vaccine for this special pandemic vaccine. So they need to stop the production of the seasonal vaccine, or they need to start all over, and that takes a long time, months,
And
at least 6 to 8 months.
Right, these aren't the eggs you buy at Wegmans. No, they have to be specific pathogen-free eggs that they come from special farms, and yeah, I think we just ordered some. They're like $6 an egg. Seriously.
The eggs are big.
Yes.
Speaking of the vaccines, now, if the flu, we get our vaccines, and we find out that the flu is different, should we take vaccines and have them anyway? If they know right away that it's.
Well, so the thing is, there was one strain that was wrong this year, but there were 3 other strains of flu in the vaccine. And those, in fact, influenza B caused quite an outbreak, much smaller than the H3, but an outbreak in the late spring. So you will be protected from the other viruses in there because those were a good match. And we always say it's hard to put the numbers on it, but there is evidence that vaccination does reduce the severity of the illness. So even if it didn't protect you from getting infected in the first place, which is what we really like, it may make the illness either shorter in duration or less severe symptoms. So there's no downside to getting the vaccine, even if it's the wrong one. We have not seen that. People used to think that if you gave the wrong one, that would be a problem. That doesn't seem to be the case. They at worst, they're benign. At best, they're helpful.
And usually people get vaccinated before people get infected with the seasonal vaccine. So when we find out that the vaccine was not a match, it's already too late. So people already got the vaccine. And yes, I would say you should get vaccinated.
I mean, believe me, we would like to make a much better vaccine. We're trying to figure out how it works in individual people so that we can make a universal vaccine or a vaccine that can provide broader immunity in more people. But we need to understand when it works and when it doesn't to know what the problem is.
Do you need volunteers to?
Oh yeah. Oh no, there are ads all the time. We're doing an H7N9 vaccine trial starting in a couple of weeks.
And they pay.
Oh yeah, they pay, but there's a qualifier for this one. The H7N9 is an avian virus, right? we're actually testing 2 vaccines in combination. One is a live attenuated, like the flu mist. Because it's live, we have actually USDA requirements. The USDA is worried that it would get into the food supply. So people who are in the vaccine trial are actually housed in an inpatient facility in the hospital for 2 weeks, where they can't leave their room. They have to stay there. Seriously, that we do this. So it takes a special kind of person who can stay for 2 weeks in one room. But they do pay well. I don't know the exact number. I'm going to guess $2,000 or $3,000.
So if you don't have plans for the next 2
Well, and
days,
they also stick you with needles a lot, like every day. There's 2 parts where there's a prime and a boost. They're going to stick you before and after all of those. So you got to keep coming back. So it's a commitment. It really is. I mean, I've participated in some of these, not the inpatient ones, but they're not too bad if you can get back and forth to the vaccine center easily. So what we end up doing is testing on a lot of graduate students and staff.
the ones that need money.
It's a very skewed population.
How is the pneumonia vaccine? All of a sudden, we're now having to get pneumonia vaccines. We didn't used to have to do that.
Yeah, well, that's because we didn't really have very good ones, and now we're realizing, and we've made some of these vaccines, like Prevnar 13, is a new vaccine that we now recommend for people age 65 and over. There was another one, a 23-valent vaccine, so it has 23 different strains in the vaccine, and pneumonia is a problem for older people. It's also a problem for the very young, but much more for the older people. And so we know that the incidence of pneumonia has gone down dramatically after the introduction of those vaccines in that age population. There's work going on to try to make a more uniform, like a universal pneumococcal vaccine that's not specific to the strains. But we haven't made that yet. I did actually talk with the guy that invented the Haemophilus influenza and original pneumococcal conjugate vaccines, who we did here in Rochester, which is quite unique. Making 1 vaccine in your lifetime is a big deal. Making 2, and actually we did 3. We did HPV as well in Rochester. Not us, but them. But it was just cool to talk to somebody who's had that experience and actually successfully brought a new vaccine that saved millions and millions of lives. And he's still at it. He's in his 80s, but he's got a new idea for another pneumococcal vaccine that they're testing. It's in phase 2 trials. That's what we were talking about.
So what do you think? I thought it was bacterial, is it?
It is.
Okay, so are we now calling vaccines?
These are bacterial vaccines.
Okay.
Right. So, and often these pneumonias, the bacterial infections often follow a viral infection. Right, and there's a lot of studies now trying to understand the link between those 2 things. The virus might put you at risk and create an opening for the bacteria that, these bacteria are around us all the time, but they don't always cause illness.
Do you think there's a greater risk if something were to outbreak in a very dense area like Tokyo versus a more, not quite as advanced area like Kathmandu or something like that right now?
Absolutely. I mean, that's exactly what happened with Ebola. Normally it was in villages out in the jungle, and then it broke out in a city setting, and that's when it got out of control.
Yeah, one of the major concerns with the Ebola outbreak in 2014 was that they get it into a big city, because they will start spreading faster than it was in the small village that were kind of remote and rural areas.
So we're better off living in the middle of nowhere?
In some cases, yeah. Well, certainly with the zombie thing, that would have been, on top of a mountain somewhere, hard to get, and I would want to be there. Okay?
Thank you.
Well, thank you.
Thank you.